Last video we have learned how to draw the simple graph with the given degree of vertices. So today we are going to learn how to draw the graph with loop and multiple edges. So we try to recall what is the rule that we are using. Okay, for example, we have a graph with vertex ABCD. So let's say there are multiple edges between AB and there's another loop at C. We try to calculate the degree of the vertex first. So the vertex A, the degree of vertex B, and so on. Okay, if let's say now we are going to take out the multiple edges, now our graph will become this is our new graph A, B, C, C, D after we take out the multiple edges. We calculate against the degree of vertex. Okay, now you can see that after we take out the multiple edges, the degree of A and B will be minus 2. Initially, the degree of A is 3. So after we take out the multiple edges, degree of A become 1. Same happen for the vertex B. The next one, if we take out the loop, at vertex C, what happened to the degree of vertex C? Now the degree of vertex C is 2. So when you take out the loops, the degree of the vertex will be minus by 2. 4 minus 2 becomes 2. Okay. Now let's try the questions that we have. So have a look on questions A. Okay. For questions A, this is our vertex ABC. So let's assume this is our vertex ABC. So when we take out the multiple edges, okay, let's say the multiple edges is in between vertex A and B. So the degree of A will be minus by 2. And the degree of B will be minus by 2 also. And the degree of C remain. Now we take out the loops. The loops will be at vertex C. The degree of vertex C will be minus by 2. Degree of A and B remain. Now we take out the vertex C. So the degree have to be minus from the other vertex. So the degree of C is 2. We minus out from A and B. So now no more C here. The degree of A minus 1 becomes 0. Degree of vertex B minus 1 becomes 0. Now we have two vertex A and B with no edges at all. Now we try to draw out our graph. This is our vertex A and B with no edges. We add in the point C, the vertex C. Degree of vertex C is 2. The vertex C will be connected to vertex A and vertex B. So continue, we reverse the process. Now we add in the loop. The loop will be at vertex C because just now we minus out the loop from the vertex C. So the last step, we add in the multiple edges. The multiple edges is in between vertex A and B. So this is our final graph. Let's check the answer whether it's correct or not. Okay, we can calculate the degree of vertex A, 1, 2, 3. Degree of vertex B, 1, 2, 3. And the degree of vertex C will be equals to 1, 2, 3, 4. And that's the correct answer for our 6A. We try to use the same method for questions B. And now we have 5 vertices. Let's say it's A, B, C, D, E. And the corresponding degree. We assume that there's a multiple edges in between D and E. The degree of D and E have to be minus 2. The rest remain unchanged. There's a loop. We can assume that we will have loop at vertex C, D, and E. So each group, the degree will be minus by 2. The degree of C minus 2, and the degree for D and E. A and B, the degree remain unchanged. Let's say now we eliminate the vertex E. We taken out the vertex E here. Okay. The degree 2 have to be minus out from the other vertices. Okay. Let's say the E connected to A and C. So the degree of A minus 1, degree of C minus 1. B and D remain. Okay, no more vertex E. Now we eliminate the vertex D. So degree is 2 minus out from the other vertex also. So let's assume vertex D connected to A and B. 0, 1. Degree of C remain 1. So the last step, we eliminate the vertex C. So the degree have to be minus out from B. So now we have two vertex A and B with no edges, not connected to any point. Now we try to sketch out our graph. Vertex A and B, not connected at all. We add in the vertex C. C will be connected to vertex B, so that both of their degree will be 1. Now we add in the vertex D. Vertex D will be connected to vertex B and vertex A. Now we add in the vertex E. Vertex E is connected to vertex C and A. Now we add in the loops. There will be loops at vertex C, D, E. There's a loop here, here, and here. So the last one, we add in the multiple edges. The multiple edges is in between vertex D and E. So there's a multiple edges between D and E. So now we can check whether our graph is correct or not. Degree of vertex A 1, 2. Degree of B, 2. Degree of C, there's a loop over here. The total degree is 4. Degree at E, so there's a loop here also. 1, 2, 3, 4, 5, 6. So the last one, the degree of D, 1, 2, 3, 4, 5, 6, 6 also. So we check whether our answer is correct or not. Okay, degree A, B, C, D, E. Yeah, that's the correct answer. Let's try the questions B again. So there's a 5 vertex A, B, C, D, E, and the corresponding degree. We still assume the multiple edges in between vertex D and E, so the degree of D have to be minus 2, and the E also. The rest remain unchanged. There's a loop. Okay, this time we assume that there's a loop at vertex D and vertex E. So the degree of D minus by 2, degree of vertex E minus by 2 also. Let's say now we take out the vertex C. The degree of vertex C is 4. Okay, vertex C will be connected to A, B, C, D. So the 4 we minus out from A, B, C, D. Each vertex, the degree minus by 1. So that we don't have vertex C anymore. Okay. Now we take out the vertex D. Okay. Let's assume the vertex E is connected to vertex A. So the degree will be minus out from the vertex A. B and D remain unchanged, no more vertex D. Okay, the last step, we take out the vertex D. The vertex D connected to vertex B. So the vertex B, the degree has to be minus 1, becomes 0. No more vertex D. Now we draw our graph. We have vertex A and B now. With no edges. Now we add in point D. Point D will be connected to B. Now we add in point E. The vertex E. E is connected to vertex A. Now we add in vertex C. Let's say C over here. C will be connected to A, B, D, E. C is connected to A, B, D, E respectively. We add in the loops. The loops will be at vertex D and vertex E. So the last one, we add in the multiple edges in between D and E. So there's multiple edges. So we can check our graph whether correct or not. Once again, the degree of A, 2. Degree of B, 2. Degree of D, 1, 2, 3, 4, 5, 6. E, 1, 2, 3, 4, 5, 6. And the last one, degree of C, 1, 2, 3, 4. Degree of A and B is 2, correct. Degree of C is 4. And the degree of D and E is 6. And this is the correct graph also. So there's a many possible answers that you can draw.